Welcome to the Interesting Chemistry, where you will find a classroom teaching experience. If you want to enjoy a classroom teaching experience from your study room, then please watch my video of Interesting Chemistry. So today's topic is the classification of elements of the modern periodic table and electronic configuration. It's my second video for the classification of elements. In my first video, I explained you the genesis or the history of development of the classification of elements. In that video, I explained you about the Mendeleev periodic table. The Mendeleev periodic table, there are 7 periods in the Mendeleev periodic table, and there are 9 groups. Total 9 groups in the periodic table. So these horizontal, these 7, this is the skeleton of the modern periodic table. I will relate the modern periodic table with the Mendeleev periodic table, but these are the 1 to 7 periods. The horizontal rows in the table, the horizontal rows which are from left to right are called the periods, and the vertical columns which are upward to downward, that are called the groups. So in the period here in the modern periodic table, there are 18 groups. There are 18 groups. So question arises, why do we write 18 groups? Because this modern periodic table is the modified form of Mendeleev periodic table. So question may be asked, justified, that there are 18 groups in the modern periodic table or the long form of the periodic table as compared to the Mendeleev periodic table. So in the Mendeleev periodic table there are only 9 groups, total 9 groups. Group 1 to 7, 8th and 0. 1 to 7. It means the 8th group is different from these 7 groups. So and 0 is an other group. So there are total lines. But later on, each group from 1 to 7 groups are divided into A and B. A and B. So you will find there first A, first B, second A, second B, and so on. Thus, there are 14 columns. There will be 14 columns. 1 to 7 divide A and B, and these 14 columns I have shown in this periodic table. This is first A, second A, third A, fourth A, fifth A, sixth A, and seventh A. This one is 7A. And this is here first B, first B, second B, third B, fourth B, fifth B, sixth B, seventh B. Again, so these are the 14 columns. The 8th group has 3 columns. In Mendeleev periodic table and in modern periodic table there will be 3 columns. So this is the place of the 3 columns. These are the 8, 1, 2 and 3. This is 3. So you will write here 3 plus 1 column for 0 group. This is 1. So it is the total number of 18. Thus I have related the modern or the long periodic table with the Mendeleev Mendeleev periodic table. So this was the Mendeleev period. So these are the groups from vertical, and these horizontal rows are called period. There are 7 periods, and these A and B are separated with each other. So there are 18 groups in the long form of the modern periodic table. So the modern periodic table is the modified form of Mendeleev periodic table. But there are something more that you should know about. The Mendeleev periodic table was based on the Mendeleev periodic law. So you should know about the Mendeleev periodic law, which law was governed by the Mendeleev to form this the Mendeleev periodic table. That law states us that the physical and chemical properties of elements are periodic function of their atomic weights. Atomic weights. So you should know about the physical and chemical properties of the elements are periodic function of their atomic weights. That was the periodic law proposed by Mendeleev, and that was widely accepted by the then scientists. But later on, one thing I want to acknowledge you here, that at the time of Mendeleev, the scientists were unknown about the internal structure of atom. Rutherford experiment of bombarding was not conducted. We don't know, scientists didn't know about the electron, proton and neutron. So Mendeleev classified all the elements on behalf of the atomic weight. But now we are known about the internal structure of atom, that are the electron, proton and neutron. And we also know, scientists also came to know that the properties of the elements depends upon the electrons that are present in the valency shell. And the number of electrons in a valency cell depend upon the total number of electrons. And the total number of electrons are the atom is the number of electrons is atomic number. So the scientists proposed a new law of classification of elements that is called modern law. That is the same as the Mendeleev law. Only one word was changed. The Mendeleev law used the atomic weight, and the modern law used atomic number. So the atomic weight was replaced by atomic number. So again I am telling the modern periodic law, the physical and chemical properties of elements are the periodic function of their atomic numbers. Atomic numbers. So all the elements that were known at the time of Mendeleev or today, they are arranged in the time of Mendeleev, the arranged are in the order of increasing at atomic weight. And now for the modern periodic law, according to the modern periodic law, the all elements were arranged in the increasing order of their atomic numbers. I will tell you in my periodic table. So please, now I am going to start the classification of elements as well as the electronic configuration. I think the most of the students think that it's a very boring topic. But today I am going to explain you that I will try my best to explain it, that it's a very easy topic. Once you understood, then never forget. So first, please draw this skeleton of the modern periodic table. Pause this video for 5 minutes and draw a table in your notebook. Pause it for 5 minutes. So here, one thing I am telling you, please, your notebook, turn your notebook horizontally. You will find so many lines. Write first of all 1 to 18. So leave them someplace here on the left side and on the upper side, and write 1, 2, 3, 4, 5, 6 and make it table, these rows and the columns, the groups or the columns are already made in your notebook, and you have to state a line here in this way on 7. So I hope you will. I hope that you have paused the video and you have drawn this table. Now I am going to start how with the classification of the classification of the elements and the electronic configuration. So I think that you have noted this is the second video for the classification of elements. Now I will not tell you, I will tell you up to 30 elements, and rest the elements I will explain you in my coming video, next in the third video. In first video I explained the history. In second video I am going to explain up to the 30 elements, and the rest will be explained you in my third video. So only for 15 to 20 minutes you have to watch my video. So first I am writing here before you know. So as so many things you are known about the elements. Every student who is in the class 2 standard knows about the first 20 elements from the 9th class. So only you have, I am going to write only that 20 elements in this periodic table. I am going to show the place of these 20 elements in the periodic table only. So here, this first element is hydrogen. You can write here 1H1, and this is He, helium. This is the second element. So, in first period, think about this is first period. First period has only 2 elements, that are hydrogen and helium. Very clear? So, this period is called as very short period. If anybody asks you, classify the periods, this is very short period. Now come to, and if I 1s1 and 2s1, so the hydrogen is 1s1, helium He 1s2. This one is helium. So here it is 1s2. Okay? Now come to the third. This is from the second period. Now think about here number 2. Here this start will be number with 3. Lithium. If you cut the strip of this and make a straight line of these strips, you will find in the ascending order of the atomic number of these elements. 2 and 3. Lithium 3. How will you write the electronic configuration? You know very well. Li3, 1s2 and 2s1. So here there is a similarity in the electronic configuration of helium, hydrogen and lithium. The last entering electron or the last coming electron occupies s orbit. s orbital. In the first period, one s orbital, and in the second period, this is 2s orbital, 2s1. 2s1. Now, come to the fourth element, beryllium. Or beryllium, you know it very well, beryllium. I am not telling you a new thing, but only to revise you, 1s2, 2s2, 1s2 and 2s2. So it is the 2s2. Here you think, now come to this point. The first A group or the first group, last entering electron, the last electron, the last coming electron or the last entering electron will occupy in S1. Here you can write S1 because the last electron occupies S1. Lithium for lithium, the last electron will occupy S1. Which S1? 2S1. If I telling you especially here, sodium 11, lithium is sodium, then you will write here as Na, and 2H and 3S1. This one, all the electrons, the elements which are in this group will found in the form of S1. Which one S1? 4th S1, 5th S1, 6th S1. So again, and now I am coming to this beryllium. The beryllium occupies the S2. Here I am sodium, and right here magnesium. Magnesium 12 number. Here magnesium 12 number. You will write here magnesium 12 number. 1s2, 2s2, 2p6 and 3s2. This one is 3s2. For sodium this is 3s1. This is so you can write here second group or second A. This is s2 because the last entering electron will occupy the S in the form of S2. So this is the filling of S1 and S2. So these elements which are found in the first and second group, from here I will write all the elements later, are called S type of elements. This is the first classification. Now I am coming to here. VE4 to 5. So 5 number here, boron. You know very well. This is the boron. So boron is B5. Here B5. 1s2, 2s2 and 2p1. Just see the simplicity of this periodic table. P1, there are 6 electrons in P1 and these are the 6, A1, 2, 3, 4, 5 and 6. So here the filling of the p orbital starts and the continuously, gradually the p orbital will be filled like this one. This P1, this is P2, boron, then carbon, carbon 6, 1s2, 2s2, 2p2. You know, I will not write on the blackboard as you know it very well. Then P3, this is P3 for carbon 6, nitrogen 7, 1s2, 2s2, 2p3. Gradually, simultaneously, now oxygen 8, so it will be P4, and fluorine 9, it will be P5. So again, helium, neon 10 number, it is 10 and P6. It is helium is accepted, that is S2, leave it, but the neon for 10, that will be the P6. So here the filling of the p orbital starts from the 13th group, or the third A to 7th A to 0. So these elements will be called as p type of elements. P type of elements. All the elements which will be filled in this blank table, blank columns right here, they will all are the p type orbitals. P type of elements. Here S type and here P type. This portion is called as the place in the periodic table for P type of elements, and this one is for the S element. Now I have told you that there is a continuation. Now here is 10 number, and we will start the third period. So the starting of the third period will be from the 11th number. So 10 and 11. This again sodium comes here. This magnesium S1S2 I explained you. Now come to the 13. This is boron aluminium. I have written here boron aluminium. 13 number 1s2 2 8, and this one is first cell, second cell, this is third cell, so I will write here 3s2 for magnesium. This is the electronic configuration of magnesium. 2 8 and 2 12 electron. Now here P will be star, so we will write 3. Which P? Third P. This is multiplied by this third P. So you will write here 3P1. P starts from here again, and so in the same way aluminium. 14 number silicon. Silicon will be P2. Nitrogen, phosphorus 15 P3. Oxygen, sulfur, and sulfur will 16 P4, and that is chlorine 17. So you write the electronic configuration of chlorine 287. It means 3s to 3p5. So here you can write here 17. Now helium, neon, this is argon. Argon 18 number, and you will write here 288 and 3s2 3p6. So it will be p6. I think that you have understood the electronic configuration of these 18 elements according to the periodic table. Now you are well known the place of these 18 elements in the modern periodic table. Now think about the second and third period. Second and third period, third periods each have 8 electrons. You see how many electrons? 8. 1, 2 and 6, 8 electrons. 2 and 6, 8 electrons. So these are called as second and third period, called as short period. Please note it. I can explain you the first period is very short. Second, third is short period. They contain only 8 electrons. So again, I am telling you the difference. Here helium is 2 and 8. Because 2 from to here, I am adding 8, and this 2 plus 8, 10, because these are the 8 elements. And again, you will add here 8. So 10 plus 8, 18. Why? Because we are continuing from here. This one, this 18. These are the number, this is the here. So this is the third period. Now I am going to the fourth period. Which one? The sodium. So the lithium, sodium, potassium. Lithium, sodium, potassium. This is 19 number. So here this is sodium, the 19 number potassium. You will write here potassium 19, 2, 8, 8 and 1. The electronic configuration, this is 2882, you can write it, and 1, 2, 3, the 4, this one, this will be 4s1. This will be the fourth period, S1, so the last electron will enter into the 4s1. It is the potassium. So this one is the potassium. This is the, but now I will tell you something more, which when you were in 9th class, a student asked me that this is the third cell and the third cell can occupy the total number of electron 18. We told you, and still the third cell can occupy 18 electrons. The total number of electrons found in the third cell can be 18. Can be 18. There are 18 electrons can be occupied by the third cell. So a student asked me, please think about it. Asked me that why student 289? Why student 289? The last electron should be occupied by the third cell. By the third cell, because the total capacity for the third cell is 18. So the 19th electron should be occupied by the third cell. So here it is 9. This was question. But at that time I told him that after occupying the 8 electrons, the cell thinks about the satisfied. They can't take part for further reaction. So after 8 electrons, the coming electrons will go to the next cell. This was my question. But today I will explain it with other logic, with another confirmation. Think about the potassium. This is the potassium. 1s2, please write it down clearly. 2s2, 2p6, 3s2, 3p6 and 4s. 4d19. Here still there are 18 electrons. These are 18 electrons. Now we will decide the place of 19 electron. Where will go the 19 electron? Here 3d is vacant. Here 3d and here 4s. So you have to decide the 19th electron, the place of 19 electron, whether it will go in the 3d or 4s. How will you decide? This I have told you in my previous video in the above principle. The above principle in which topic, that was a rule of n plus or n plus L rule. You will decide with the n plus L rule. So please go to that video, the above principle, in which you will find the n plus L rule. But now briefly I am telling you the value. So the value of the 3d n plus L is equal to 3d. I am finding the value of n plus 4 3d. So this 3 denotes for the principal quantum number n. So here the value of n for 3d is 3. Most of the students, I think, knew about this, but some students who don't know about this, so please try to understand. So here, the value of D, L is the azimuthal quantum number. L is the symbol of azimuthal quantum number. So the value of L for D, only for D, is SPD is 2. So here you can write here 3 plus 2 is 5. It is 5. And for S, now I think that you have understood, for the value of L for S is equal to 0. And this is 4 plus 0. N plus L, and 4 plus 0 is equal to 4. Now here this is 5 and this is 4. This is 5 and this is 4. So I told you in the N plus rule that if two or more orbitals have the similar value of N plus L, this is the second part of the N plus rule which I am going to do, which I discussed you, but first I will tell you first part. The newly entering electron will occupy that orbital which has lower N plus L value, because the order of increasing above principle, I explained the order of filling of the orbitals, that is according to the increasing order, because the orbital that is lower will be filled first, and that is the orbital that is higher in energy will be filled later. So from this, which one is the value of N plus L, value of the 4s is lower than the value of 3d5. So the electron will go to 4s, not in 3d. This is the decision from the N plus L rule. I will explain you later on. So I think that you have understood that the electronic configuration of 2881 is correct, and this will not 9, it will not 1, because the entering electron will occupy the orbit, because the electron, first thing you think, these two electronic configuration are differently called. This electronic configuration is according to cell, and this, because this electronic configuration is according to subcell. If I write here px1, p2, 2px1 to 2py1, then if you write in this way, that is according to the orbital. I have explained in my previous video, so please watch this video to know about the type of the electronic configuration. So this is about the 9D. Now you have understood the electronic configuration of calcium, that is calcium 20 and 2, 8 and 2. Now it is 2. Again, now come to the 12. This is again, P20, and now this is 21, scandium. Here, this is 21st element, that is scandium. Scandium is the 21st element in our periodic table. So, right, so please remember the electronic configuration of 2, 8, 8 and 2. This is the electron. So now you have to decide about the 21st electron, which place will be occupied by the 21st electron. So please, this is scandium 21 and I am writing here 2, 8. This one. This I will write here 3s2, 3p6, 3d is there, that is vacant, and these 2 electrons are in 4s2, and there is also a p. There is a also p. In the third period after the p orbital, 3s, the electron goes to 13. In aluminium, I am telling you, the magnesium in this, suppose here 2, 8, 8, 2, and for aluminium 13, the 2, 8, and this one 3s2, 3s2, 3p1, because here no d. In 13 second cell, there is no d. There is only 2 subcells that are s and p. Here there is no d. So the electron goes to the p1. Here for the 13 electron I am telling you, because here there is no 2d. So the electron will go to the p1 here. But here in the case is another case. Here the presence of 3d tells us claim to have the electron. 3d is here also, and here 4p is there. So there are 2 orbitals. One is 3d and second one is 4p. Now you have to decide. Now you have to decide in which orbital the electron will go. So here, calculate the n plus l with 4 3d, n plus l, here 3 and 4d, d is 2, so here you can write here 5. And for 4p, so n plus l value, you will write here 4, and the value for l for p is 1, so here again 5, again 5. In previous case, the value of 4s was lower to the 3d because the value of 3d was 5 and the value of the n plus l was 4s is 4. So the electron occupied by the 4s. But now here think that 3d, you have to decide the 21st electron either 3d or 4p. So here both the orbital have similar value. Both the electron have similar value. So decide in which orbital the newly coming electron will enter. So here, this is both the. So now the second part of the n plus l. First part I told you, the lower energy and higher energy. Lower energy orbital will occupy first and the higher energy orbital will occupy later. But when the 2 or more orbitals have the same n plus l value, then the entering electron or the coming electron or the newly entering electron will occupy its place in that orbital which have the lower value of n. The n will decide. N will decide. So here this 3d and 4p which have the lower value of n. The 3d is from the third cell, it is from the fourth cell, so the 21st electron will go to the d1 and this p will be remain vacant. So here, the opening of the d orbital, the presence of the orbital, the starts the filling of its electron. So here, the scandium 21, here start D1. Start D1 here from this D1 and think about the easiness of this periodic table. These are the only from here to here there are 10 columns. There are 10 columns, so D1, D2, D3, D4, 5, 6, 7, 8, 9, 10. Now the filling of the D orbital starts from D1. So you should know scandium, titanium. You can write the titanium number 2 to number 22. Titanium, T, vanadium 23, chromium 24, chromium, molybdenum, no, manganese, Mn, 25, iron, cobalt, nickel, 26, 27, 28, and here copper, 29, and here Zn, 30. This I have. Please so remember these characteristics. From this here, you can remember all the elements. 20 up to calcium, you know very well. Only 10 elements you have to remember. This is scandium, titanium, vanadium, chromium, molybdenum, iron, cobalt, nickel, and copper and zinc. And you can, the atomic number will be in ascending order 21, 2, 3, 4, 5, 6, 7. So this one is D2. So here titanium 22, it will be 3D2 and 4S2. 3D2, 4S2 remain the same. Vanadium D3, D3, and 4S2. But here I am telling you, surely it is D2, it is D3, and it is chromium D4. I have written chromium. Yes, chromium D4. So please understand the electronic configuration of chromium. This is an exceptional case. I have explained in the influence of the Dobreiner principle. You will find in the electron some exceptions. So it is the first exception. Chromium is the first exception. I have, according to the rule, according to the law of periodic, modern periodic law, the chromium it is 24, chromium 24. So the electronic configuration of chromium must be 3s2, 3p6, 3p6 and 3d4 and 4s2. 4s2 from calcium and D open the D1, D2, D3 and D4. So D4. It is D4 according to the modern periodic law. But it will be wrong. It will be wrong. Here you have to write one electron from 4s2. One electron from 4s orbital. One electron from 4s orbital will migrate to the 3d, and the electronic configuration of the chromium will be 2, 8, 3s2, 3p6, 3d5, 3d5 and 4s1. Please note it. So many times this question is asked in your examination. Write the electronic configuration of chromium, and most students write in this way 3d4 and 4s2, but it is wrong and this one is correct. This is an exception in the modern periodic law or the Mendeleev periodic law. So here you will find 3d5 and 4s2. This chromium. Again, this manganese, so D4 may be D5 and D it is manganese will be D5. Again Mn25 it will be 3D5 and again the electron, the 25th fifth electron will acquire this 4s2, 4s2. You can ask me that why this exception is observed here. What is the reason behind it? That one electron is migrate from 4s2 to 3d, and this 3d becomes the d5 and 4s1. You can ask me. It is also a question. So please remember that half-filled orbitals are more stable than unfilled orbitals. Half-filled orbitals. I explained in the above principle. So this is through this 3d5. This 3d5, because the total number of electrons are in d is 10 and 3d5 is half-filled orbital. So the stability of this 3d will increases. And I also explained the cause behind the stability, why the stability of the half-filled or full bit increases than other orbitals, than other incomplete filled orbital. So I explained. So please watch my video in previous video. So here, this is I have explained you. So here, this is d5, and this will be d6, and this seventh electron will be 27. First electron is d1, and so the seventh electron will be d7, and nickel in d8, here d8, and the copper d9. Copper d9. Again, come to the copper. It is also a exceptional case. Copper Cu29. I think that you will understand this. Cu29, it will be written as 1s2, 2, 8, 3s2, 3p6, 3d9, and 4s2. But it is again wrong. It is also exceptional. This migration of here with the repetition 3d10 and 4s1. 4s1. So one electron will migrate from 4s2 to 3d9, and 3d9 will be formed as 3d10. Again it is fulfilled. 3d is fulfilled. So the stability of the 3d10 will be increased. To acquire this stability, one electron is migrated from the 4s2 to the 3d9. So the electronic configuration of Cu29 will be 3d10 and 4s1. I think that you have understood. So it is 3.3, and less. This is zinc. This is Zn30. You can write here 3d10, and the 30th electron will occupy in the 4s1. Again it is 4s2. So this all about the up to 30 electrons. One thing more, I told you that multiply with this second. So second P1, second S2, second P1, second. So this 3 S2, 3P1, 3P2, here 4 up to 20. This is 4S2. But in scandium, the electron goes 4 minus 3. So you will say here n minus 1. Here you will write here D. D will be 4 minus 1, 3D. This D is for n minus 1. So here you write here, please note it, that you will won't multiply with for the D from here, because it is D n minus 1, D 4 minus 1, and this 3D. So this is the these are the D. This is 4D, this will be 5D, this will be 6D. 1 is less. So that's okay for the today's video. I have explained you in very simple way according to the and in the next video I will explain you about the rest element, the configuration of the rest elements, which will be filled in this way. So I think that I have to, this is S-type, you are classifying the S-type elements. These are the P-type, and these are the D-type elements. These are the D-type, these are the D-type elements. So, and again, one element is that is F type elements. I will discuss in my next video. Please share it. If this video, like it, and give your comment about this my video. Then I can improve my teaching with your comment, because the today's technology, we were the teacher and we also examine to our students, but today this is modern technology. Students are examining the teaching of the teacher. So you are teaching, you are watching this video and also examine, also evaluating us whether we are a good teacher or a bad teacher. This is the benefit of the modern technology. So please, I request you to comment on this video, so can I improve my teaching for you. That will be very helpful. So again, like it, share it and comment it. So if you will like, share and subscribe, my coming video will notify you in the next few days. So for today, it's okay. Thank you very much.